Good afternoon, everyone. Welcome back. Pleased to introduce our next panel. The moderator is Thomas Roberts. He's a PhD candidate in the MIT Aeroastro department. He's a graduate research fellow in ARCLab and an adjunct fellow at the Center for Strategic and International Studies in Washington, D.C. His research interests include Astrodynamics, space sustainability, and international space policy. Look forward to this conversation. The floor is yours, Thomas.
Yeah, thanks, Mark. It's my pleasure to be here. On Monday I defended my PhD, so I guess I'm no longer a PhD candidate. This is my first time saying that in a public setting like this, so that feels really special. And what is also special is the opportunity to share our panelists' expertise. So maybe because I passed my defense, I feel more empowered to sort of challenge some of the notions with which we approach AI technology development here in the department. I find that if you are a motivated young student interested in developing AI technologies for space applications, you'll be perfectly at home here in the department. There are plenty of labs around who would be happy to hire you and contribute to some of their funded research projects. And there's a little bit less oxygen to talk about some of the security dynamics at play with implementing some of these ideas. And so I wanted to bring in this panel of experts to sort of talk about some of those challenges, but also ways in which AI technologies can directly support some of the peace-building measures we've seen around the world, especially in multinational fora. So I want to introduce them very briefly, but I'll also give them a chance to introduce their organizations, their perspective with which they approach this work, and if they have any specific comments about how AI technologies interfaces with their own work as well. So from left to right, we have Brian Weeden. Brian is the Chief Program Officer of the Secure World Foundation, which is dedicated to the development of a more sustainable and peaceful space environment. Just this week, the Secure World Foundation published the latest iteration of their Global Counterspace Capabilities Report, earmarking all around the world the developments in testing and demonstrating counterspace weapons, or technologies that threaten on-orbit systems and the ground stations that support them. We also have Dr. Jessica West. She's a senior researcher at Project Ploughshares in Canada, focusing on space security. Her portfolio is vast, and so is Project Ploughshares. But what I like most about Jessica is she's also a whisperer from multinational fora proceedings around the world. So I don't get to go to Vienna or Geneva for those sorts of meetings all the time. I'm talking about those United Nations meetings and specific legal proceedings. Because of you, we have a better understanding all around the world, so thank you for being here. And lastly, we have Ms. Kaitlyn Johnson. She's the Deputy Director of the Chief of Space Operations, the top general in the Space Force, and their Strategic Initiatives Group.
Yes, mouthful.
And so I think we'd be remiss to have this sort of conversation without a representative from a military service, and why not the US Space Force if we're right here in the United States. And with that, I want to hand over to Brian.
Sure. Thank you, Thomas, for the introduction. Also, I was on Thomas's committee, so yeah, you did a great job yesterday. So what do we do? So Secure World is a small, privately funded nonprofit. Our focus, as Thomas mentioned, is how do we ensure the peaceful and sustainable use of outer space for benefits here on Earth? And that last part is really important because we see that space could be, has been, and can be even more so in the future, hugely beneficial for life here on Earth. So a lot of our work is focused on things like space debris, space traffic management, space situation awareness, and then of course also the security efforts that Thomas mentioned, because all of those are big challenges to that long-term sustainable use of space. Me specifically, a lot of my role is translating from the technical world to the policy world. My undergrad is electrical engineering. I spent about 9 years in the US military doing space and nuclear operations. My PhD is in public policy and public administration. So I have one foot sort of in the technical world. I can mostly understand what you guys are talking about, and I recognize some mathematical symbols, and I can fake it a little bit, but a lot of what it is how do we take these brilliant ideas coming from the engineers, the scientists, and translate to something we can bring to policymakers to actually address some of these very big challenges. And sometimes that runs both ways, right? Sometimes that is talking to the policymakers and studying sort of the governance challenges and then saying, these are some issues we don't have any good data on or we don't know anything about. And then going back to the technical community and saying, hey, can you do some work on this? Can you study some stuff and help us answer some of these questions? So I'll say in that world, obviously there's a lot of talk about AI. I'll say most people in my world have no idea what the heck AI is. And if you ask them the difference between a machine learning algorithm and a large language model, they don't even know what those terms are. So there's a huge educational problem in talking about that. But at the same time, they care very deeply and they think it's really important because they feel they're supposed to think it's important because it's the new next hot thing. So that is a huge challenge that I have to overcome. And just I'll close by saying, I think there's certainly a huge amount of room for AI writ large to help address some of the problems I briefly mentioned earlier. But man, there's a lot of challenges to overcome in implementation, in administration, and all those sorts of challenges. So we'll get into more of those as we go along.
Thanks, Brian.
Great.
Jessica.
Yeah, hi, I'm Jessica West. Unlike Brian, I don't do math, but I was wildly inspired and in awe of especially the pitches this morning, which were fabulous with math and storytelling, so kudos to everyone there. My background is in international security governance. My PhD dissertation had the F word in it, Foucault. So I looked at how changing approaches to science have informed different military strategies. It's not something I get to use in my day-to-day, but I think it's something that's going to come out in our discussion today. So I'm excited to dive back into some of that. Currently, I work as a senior researcher at Project Ploughshares. We are a rather small NGO in Canada. We're a peace-focused organization. Our focus on peace, though, which is a very broad topic, is largely on the hardware of warfighting and how to regulate that, particularly from a disarmament and a human security perspective. So my colleagues do more of our flashy work, I would say, on nuclear disarmament, the Canadian arms trade, and then I have a fabulous colleague, Branka Maria, and I encourage you to look up her work. She is our AI expert. So you're stuck with me today, the space person, and I'm going to try to wear Branka's wonderful and extremely intelligent hat. But our approach to AI from that perspective is very much focused on military applications and the ethical and legal implications of those applications, and also where the ethical and legal boundaries of those applications should be. So Project Ploughshares is a long time and early member of the international campaign to ban the use of lethal autonomous weapons. We work with and through UN bodies on that. Different ones than I go to. That's the Convention on Certain Conventional Weapons, but it has its own dynamics. We don't often cross paths, Branka and I, the AI side and the space side, and I find that's really typical in governance. We have technology silos, even though technologies interact wildly, and I'm surprised we haven't really been talking about other technologies today, such as quantum and cyber, which I think are very much entwined in the AI discussion. Maybe we'll get to that as well. But our governance is also very siloed. And so I think we have a huge opportunity to look at what is happening in other areas of governance. So there's a lot of AI initiatives focused on Earth that we can maybe bring to outer space. But we also have to think about how this technology is going to be constrained by or outpace the boundaries of our existing governance in space. And I think we're already struggling to govern space adequately. And so when we start throwing in a lot of new technical capabilities that change how we behave and interact with one another in space and what we're able to do, really we need to have more PhDs on space governance. I guess that's my pitch here. And
Sounds good to me.
I'll end there.
Thank you, Jessica. Kaitlyn.
Yeah. Good afternoon, everyone. I'm from the government, and I'm here to help. And with that, I must give you my usual caveat that a lot of what I will say is, yes, informed by the role that I sit in the Space Force, but it is, in fact, all of my own opinions. And as many people in this room know, I'm incredibly opinionated. So wild that the government hired me. Prior to being at the Space Force, I worked for 8 years at the Center for Strategic and International Studies doing space policy research. And it does not escape me that you have like sustainability, peace, and then war over here. No, it's actually not true. The Space Force wants to go to war the absolute least, I think, of anybody. And we are building our mission and our people around the ability to defend civil and commercial and, of course, security assets in outer space. I thought I'd give you kind of the overview of the current landscape of AI policy in DoD. And I will say, I did not write or was involved on any of this policy. So if you have really detailed questions, I will refer you to anybody else. But the first is that there are a lot of AI initiatives across the Department of Defense. And I think this is really interesting in two ways. One is that DoD in the American government budget ecosystem has the most money. So you will see a lot more activity coming out. I know Dr. Linares' lab, of course, gets some Space Force grants to work on AI things. And I see a lot of nods from a lot of those students and researchers,
out there.
some beneficiaries of these grants. You're welcome. But it is true that a lot of this innovation and funding is coming from the Department of Defense. And so with that, we are also the most risk-averse agency in the US government. We have a lot more at stake. We have actual lives at stake. And so trusting AI, which I think we'll dive deep into, is going to be incredibly difficult in the Department of Defense, let alone across the US government. We do have an adoption strategy, and there is a lot of challenge within DoD and US government of actually adopting AI practices or models or metrics or incredible tools that you all are building in the outside world. And so I just wanted to kind of overview how the DoD sees this adoption strategy, and I think they've described it in an interesting way, which is that it's the shape of a pyramid, and at the base, and most important, is this trusted, high-quality data. And I think you can all agree on this, but this, again, goes back to that risk-averse culture, that not only do we need to be able to trust our data, we need to continually update and improve it. The middle is this insightful analytics and metrics, or maybe even the foundational models or visuals required for DoD leaders, those people who have probably no interaction with AI before, and this education gap that Brian mentioned earlier, where they are going to be interacting with it. And then the top is responsible AI, and this is DoD's approach to ensuring that the design, development, and use of AI capabilities are in line with AI ethical principles, which you can also go out and Google all of those. What I really like, this quote really grounded me, and I think it, from this 2003 DoD data analytics and AI adoption strategy that I read just for you guys. It says, risks will be managed not by flawless forecasting, but by continuous deployment powered by campaigns of learning. So there's definitely some DoD jargon in there, like campaigns and deployment, very military terms. But to me, this reads that we have to continually update and remodel and reforecast and reconfigure our models and data to be trustworthy, to be ethical. You all know better than I do that old data is often bad data, but sometimes you have no choice. And I think the panel this morning had a great example of this. You had, as Adriana said, Planet, who has pictures of the entire Earth every day, and then you have pictures of Mars, which we have like 20 of. I thought that was a really great example of this. You do the best with what you can, but sometimes for the Department of Defense, where we have so much at stake, this is where these challenges and barriers of adoption are coming from, and it's because of the lack of comfort and trust. And I think those are going to be some of the biggest hurdles to overcome, not just building trust and confidence and comfort with AI tools amongst the DoD military and all the DoD users, and breaking through this highly risk-averse culture, but also breaking through this traditional acquisitions model. So I'm not sure how familiar you guys are with how DoD buys things, but it's really actually great at buying like an airplane or a ship. It's less good at buying satellites, especially in large constellations that are replicated and that are updated every couple years. That's why you see a lot of the really big, as General Raymond, former chief of space operations, said, big juicy targets up in space, GPS satellites, things like this. Obviously, those models don't work for AI. So not only are you guys overcoming this risk-averse culture, we're also overcoming this incredibly structured acquisition culture that is very good at big one-off products that are exactly the same every time, that we know how to maintain and build and operate. And that, I think, is kind of antithetical to what the future of leveraging AI across the department can actually be. So we're fighting an uphill battle.
I think that was a great introduction to sort of the spectrum we're going to see in AI adoption. And I was taking notes all day today about some of the previous presentations, and I think some of our speakers shared some of the goalposts of this spectrum that I think that are relevant for military applications for AI as well. So one of them was our guest from JPL mentioning that AI technology is developed from an engineering perspective. That Mars rover, they're excited to deploy these new tools to make it work better and more efficiently. But they're up against the science team. And he said up against society, who thinks they're looking at their billion-dollar rover and saying, absolutely not. We have our methods for deploying a command and control over this rover, and we're not going to change the reins over to something that might pop its tire on a rock. On the other end of the spectrum, our guest from Planet was juxtaposing the history of using film footage, a handful of images to monitor the Earth's surface, and we had maybe a team of 50 to 100 analysts looking at very few images with their eyes, and now we have 30 terabytes of data every day. That's a solution space where AI is very well welcomed. It's perhaps much lower risk than the one described by our guest from JPL. So I'm curious to see where you think you fall along that spectrum in a few different questions. My next three questions are dedicated, one for each of our guest panelists, but I want you to always be able to jump in after anyone's asked a question. So the first one's for Kaitlyn, and specifically I wanted to ask, how do you envision AI reshaping military operations and strategies in outer space? And you mentioned ethical concerns. What are those ethical concerns, and do you think that they're related to strategic considerations, and what warrants extra focus in your mind?
Yeah, so I think this conversation is still ongoing across the Space Force, and you can see this in a couple different ways. We had a memo released in September from our Chief Technology and Innovation Officer, Dr. Costa, as well as some other very government documents released shortly after about how the Department of the Air Force, which the Space Force falls under, is going to approach AI. Here's a couple of things that I thought were really interesting on how the Space Force is currently investing in an AI and how we could continue to do so and use it. One, and I think this is going to be surprising to nobody, is through the sheer amounts of space situational awareness data that we use and consume. Space Fence, of course, captures way more data than we were used to beforehand, and then on top of that, we are still aggregating and adding all sorts of different methodologies or modalities of data. And so not only being able to understand and characterize that data, develop ways to identify patterns of life or behaviors in outer space, which can alert the military perhaps to unusual behaviors or maybe even threatening behaviors. But then also, how do you plan safe maneuvers or safe operations knowing what's around you constantly? And so I know that there are many people working on this today, both leveraging the opportunities that AI can bring to distill all of that large information and make it a repeatable, learnable process, but also to visualize it and be able to operationalize and train Guardians. So when you hear the Space Force talk about AI, a lot of what you'll hear is how they're going to use it to support operational training test infrastructure, and then also how we are going to hopefully get it into the hands of Guardians, these tools and models for them to leverage in their day-to-day operations. I think one fear that we heard earlier, which I think is still true in the Space Force, is AI going to replace my job? The Space Force is extremely small relative to other military services. We have about 9,000 active duty service members, and we have about another 4,500 civilians who support the Space Force, and including me. And while I would say no, it won't take away your job, it will supplement right? We are short-staffed and we are small and intentionally designed to be so lean and agile. Congress did not want to create another massive behemoth military organization. And so when we look at AI, we see this as a tool that will free up some time and opportunities for our service members to then be able to go off and accomplish bigger and better things by making these more repeatable routine processes automated or supplemented by AI or ML.
So one military operation that's already in play is distributing collision avoidance messages using the 18th Space Command Squadron's SpaceTech database. So anyone I'm looking out at the audience, I know which spacecraft operators various people have worked for, and you've probably been the recipient of this onslaught of emails describing which other satellites are currently threatening your on-orbit systems. And it's too many to process. Like that's a particular opportunity to apply AI. It could be the company itself filtering through their thousands of messages every day, or it could be the operators of the SpaceTech database. So I'm curious.
Well, it also will help us have more fidelity in those emails, right? Whereas now you might get 100 emails because we're not 100% sure. Maybe that'll help us narrow and be a little more confident when we send out those emails. So then instead of sending out a million, and this won't be the job of the Space Force anymore. It's going to Commerce. But Commerce can use it to not send out so many emails. Yeah. Phew.
So I wanted to open up to Brian and Jessica, too.
I would just say, look, one of the biggest challenges here is got to keep in mind that the military is a bureaucracy, right? And it generally solves problems with people and bureaucracy. I am, having looked at decision-making in my PhD focus, organizational behavior and culture drives so many things. It is shocking when you go back and look. And one of the biggest challenges that large organizations have is in technology. And adopting technology and rolling it out and doing all the training and all that kind of stuff. Short story, nearly 20 years ago, as a young captain, I got to do the job of this, of going and taking all this data in on where stuff is in space and updating the SpaceTech catalog from Cheyenne Mountain in Colorado Springs. And at the time we were doing that, we got trained how to do it on this system. So this is a little trip through computer history, so bear with me. It was a IBM S390 mainframe whose speed is measured in 2 digits of megaflops, for you people in the room who understand what that is. And we were using terminals running a VAX operating system, like predated GUIs, right? And we were told, well, that's going, because that was old at that time. This was the early 2000s. It was old at that time, and we were told on the way it's going away, get a new system. That system is still around today, and while it is not being used to do the primary part of the mission, it is still there and is still playing a role in these systems 20 years after it was supposed to be like sent away. Latest I've heard is they're running in a virtual machine, right? So they basically virtualized the software so they can run it on modern hardware, but it's still around because it was so deeply embedded in all these other systems and connected to all these other things and all the communications pipelines that you're talking billions and billions across multiple organizations to rip that out and replace it. It is just a massive challenge. So it's not that they didn't want to. And that is one of the biggest problems in organizations like the DoD and other large organizations adopting these new technologies. There's just a huge problem with the installed base of users, the existing culture. And just on that really quickly, this whole system is originally designed around having a trusted set of sensors that you own and operate and control that are providing highly structured data in specific formats. And there's a centralized system that takes all that in and produces a solution, right? Now you can imagine that the organizational culture built around that suddenly being proposed with, hey, we're going to decentralize and we're going to take all this crazy amount of data from commercial people and academics and it's going to come from many different sources and you may not know if you can trust that. And it is just, there's a lot of, hold on, So again, the organizational challenges implementing all stuff is just huge. And that's not saying that people are active, don't want to do it. It's just hard to overcome.
Jessica, what do you think?
Yeah, and I'm hearing a lot today about the challenges of trying to get AI integrated into space because of a risk-averse culture and $14 billion missions, bureaucracy. But I think when we look back at history, we also know that there are times when there are very rapid revolutions on the battlefield. And if we are thinking about peace and security in outer space, we are kind of thinking about outer space as a battlefield, although I don't really like that term. So I'm more of a believer. I think there's going to be changes in how we do space strategy from a military perspective in outer space. And I think it's very much going to be shaped by artificial intelligence. And I'm worried a little bit about that. I think one of the biggest drivers is going to be speed. So I think things are going to speed up as we are able to do faster detection and, in theory, faster response through the use of computers that can think, that can process more information. But there's pitfalls to that. You know, we're not new to this in space in some ways. We've had missile early warning systems being detected from space and sending warnings to people for a long time. But we've always relied on people in the loop to have the sober second thought and in many cases to not believe what they were being told by computer systems about incoming missiles. And I think that is, someone asked today why we need humans in the loop. I think that is a really important reason. Also for international law, we need humans in the loop because we have to have accountability for what we do. But with speed, I think we get away from that. And I think I think we're going to start hearing that phrase because we have to. We don't have a choice. Others are doing something, and so we don't have a choice. We have to follow along. We also have to do that. So because we look a lot at arms racing in my organization, that's where I have some concerns. But I think it's going to be really a focus on speed in decision making, speed in response, speed in detection. And I think that will change the strategy, and it will change the architecture as well. So for those of you doing robotics, so Ploughshares' work on swarming and so that's where I think there's going to be changes in strategy, and but those often come quickly, and it can take time to catch up from a human perspective in terms of what are we doing and how are we using technology. So I hope we don't have war, and I hope we don't turn outer space into a battlefield. But I worry that we lose opportunities for de-escalation, for sober second thought, for communicating, and for human interpretation on what's going on when there is more and more emphasis on doing things quickly and relying more on speed. Because I know I default to a computer, and if a computer tells me something, I'm likely to question myself rather than the computer. And I think that's human nature. So we are sort of biased in some ways towards
And I'll just add,
the machine.
Those people in the loop you mentioned have kind of saved our butts a few times collectively in the last few decades.
Yeah, it's not all bad though. We can talk about the good stuff soon.
Sure, but maybe we could dive into that right now. I want to share a few hypothetical examples based on some of the conversations I've had with folks in the room, but also hearing your presentations earlier today. About humans in the loop. So right now, the largest and most dense satellite megaconstellation uses automated collision avoidance maneuvers and loves to advertise the number of maneuvers it's performed, its willingness to very, very temporarily pause its mission in the name of space sustainability. Another member of my lab earlier this week, he mentioned, I've noticed talking about me that I sometimes rattle off the name of historic satellite collisions or times in which a satellite's been threatened by the natural or human environment in the space domain. And I can do that because there's been so few that we can name. And what if I were to hypothesize to you that the next collision would be between at least one satellite that uses automated collision avoidance based on an AI-driven system? What might be your response? What could you predict about the environment as it might change as a result of that story?
So first, I'll say I was on a panel with a bunch of Astrodynamics nerds about a year ago, and this came up. And I said, well, first of all, if you'd asked that community 5-10 years ago, could you do autonomous collision avoidance for a constellation of 1,000 satellites? The collective answer is no, that's not possible to do. And yet, we're doing it. So, once again, SpaceX has proven they're pretty darn good at engineering solutions. One of the biggest questions that comes to mind is, what does that mean for fault, right? Which itself is already a very difficult, complex, and nebulous question in the space world. Because under the existing outer space treaties, if something happens on orbit and there's damages, you have to prove fault in order to collect on those damages. And by the way, that is structured by default as a diplomatic negotiation between launching states. So you've already just created the most difficult problem in the world, right? Two countries trying to negotiate with each other. And you have to prove fault. And oh, by the way, there's now some automated system in the loop that may have made a decision that humans weren't involved in. So how do we do that, right? So that is a huge challenge. And I'll say the other thing that I wonder about is so Starlink is doing a wonderful job of this autonomous collision avoidance for their own constellation. Will all the other large constellations be able to do the same engineering trick? And what happens when you have more than one constellation with their own machine learning AI algorithm doing their collision avoidance conjunction assessment with different parameters and different risk profiles, making their own independent decisions? How is that going to work? And then how does that complicate all this other stuff? So, those are the things that immediately pop into mind in that scenario you're describing.
Are there any specific mechanisms that either Kaitlyn or Jessica could think of in advance of that sort of crisis? Right? We haven't had it yet, and there is a world where we can avoid it forever. So for those in the room who are less familiar with some of the bodies at play here and decision-making players, what can they do in advance of that sort of event?
Yeah, I completely agree with Brian, and those are the mind-boggling questions that go through my mind as well. And to do a play on his very excellent 2014 article, Dancing in the Dark. I've been thinking about how the fact that we're coding in the dark in many ways, where we don't understand, we understand our own system, but we don't understand what the other systems are doing. We might know where objects are, but we don't know the assumptions and the norms and the values that are informing how they're being operated. So one thing, if there were a collision, I would think, oh, we probably didn't get our act together and create norms or rules of the road for operating in outer space from a safety and a sustainability or a space traffic management perspective. I think having some of those rules and norms inform AI or automated operation of satellites and constellations is essential so that they're similar. So standardization of how we think about what we do in situations, I think, is really important. And it's probably not easy. I'm assuming there are different risk tolerances, different values across corporations as well as countries, but certainly it's something we could work on. And I think we would benefit from a bit of a culture shift in both AI and outer space. Both, to me, are heavily secret. Layers of not a lot of sharing. We're not great at sharing. And I think this is a situation where, at least on the civil and the commercial side, a drive towards interoperability, towards understanding how things are coded from the back end would be important. It's sort of like understanding different cultures and how people in other countries are thinking. Diplomats have to do that all the time. And so I think bringing some of these softer skills and tools into the development of artificial intelligence systems would be really important. I just can't promise that we're going to get our act together and do it. But again, I think this is where today's conversation is so great, because you have to have people on the technical side who are grappling with these problems say, hey, we need solutions at the global level.
So one quick example to back that up. A few years ago, there was a scenario where OneWeb was raising one of its satellites through the Starlink constellation to their operational orbit, and the OneWeb orbit is much, much higher. And there was a predicted conjunction between a Starlink satellite and the OneWeb satellite. And there was a big back and forth between the companies that spilled out into public, with them accusing each other of irresponsible behavior because they had different risk profiles and different processes, right? So Starlink was essentially saying, well, our system first of all, they said, we don't even think this is a big deal because our risk threshold is different than yours. But even if it was, our system does an autonomous maneuver 48 hours ahead of time and whatever, let's let it go do its thing. And OneWeb's like, no, we need to coordinate this, and we wanted to maneuver ourselves to make sure it's okay. We don't really trust your autonomous maneuver. And oh, by the way, there were 4 different SSA providers that gave 4 different estimates of the collision probability for this one event, right? And no agreement there at all. So this is one scenario with 2 satellites, and it turned into this whole big thing. And so now you're talking about, putting machine learning, AI models in the loop, or thousands of satellites, and man, that gets really challenging. But it's a real issue. It's a real issue that people are grappling with right now.
I've got another scenario from another panelist on Adriana's panel, Victor, who mentioned a paper that came out yesterday in which he and his international team of collaborators designed a chatbot, really, that allowed a user to communicate with a satellite. And they could, instead of having a spaceflight dynamics team who was given mission parameters about how to perform an upcoming maneuver, you could just write to the satellite and say, maybe I want you to decrease your risk tolerance to maneuver less often in the face of a collision that's been detected. Imagine that kind of world where instead of using traditional education in astrodynamics or orbital mechanics, we use AI to change the dynamics of satellite operations. Could you see, Kaitlyn, a future in the Space Force for an organization that was responsible for training and equipping spacecraft operators to use a technology like that? He called it crazy. What would you call it?
Crazy. It is a highly risk-averse culture, and therefore the human in the loop or even on the loop, which are different, right, is incredibly important. I think one of the biggest challenges is going to be building that trust in DoD, right? And I think there are really easy ways to start building this trust. To get after some absolutely boring government stuff, we have to do. So here's a great
But important, right? But important.
Really important. But I fill out a lot of paperwork in the government, way too much paperwork. That is something that clearly could be automated, right? The government knows that I am traveling to Boston. I have to submit that. I have to submit where I'm going. I have to submit ethics waivers. I have to book hotels and flights. How could that not be some automated interface process for the government to be like, we see you are going somewhere. Here are all the steps. Here are all the trainings. I think this flight might really work for you, or something like that, right? Just on a basic level where there's low risk and high interface between someone average like me working and interfacing with AI in the government. Same could be said, the active duty service members across the military move or change jobs every year or 2. It is absolutely wild how often these families have to move across the country. They know that these people are going to move in January, and they don't actually have to move until June, right? So having that AI interface, maybe a little chatbot, say, hey, we know that you have a permanent change of station coming up. You have to move to Colorado. How about we start helping you fill out all this paperwork, and the AI actually, based on your past history and all the information in the database that the government already has, fills out some of the paperwork for you, and you just kind of check it, right? You start building these small, really low-level trusts across the department for people to get used to working with AI. And then maybe you can start asking the bigger questions of how do we use AI in scenarios where the risk is extremely high if there's that lack of trust or if the data is wrong. And so I think until then, you'll more likely see supplemental possible AI, things that help maybe diagnose malfunctions or issues with a satellite based on patterns of life or previous historical, hey, we analyze data. This looks really similar to what happened in 2022, and this is what happened to the satellite then. Here's our proof, and then you just have a human operator double checking that work versus doing that. Right now they do that work themselves 3 times over. They've got 3 different people who will sit down and do the mathematics and the process and then all agree. And that's how risk adverse we are. And that gets to the speed problem of when there is a decision that needs to be happened, maybe it's maneuver, diagnosing the confidence, but then also the plan for maneuverability could be highly automated to at least provide options that a human would double check, or a human would agree with the assumptions or question the assumptions that the AI tool made, to then give a best informed or even make that decision. And maybe there is an amazing step that the AI actually performs and supports the maneuver itself, but probably more likely it will be a human who actually does that kind of maneuver, because again, you need accountability in the government. Congress needs somebody to call if someone goes wrong. And that's why I think the full adoption is way out there, but the small supplemental to make people's lives easier is the most important.
Lower hanging fruit.
Yeah.
When I first heard of the technology from Victor's paper, one of my first ideas was, if you have like a small space company with 5 recent MIT grads, I think you will find a spaceflight dynamics operator on that 5-person team. But what you might not find is a legal department. And so what if you could inform a chatbot with all of the rules that govern international coordination in the space domain? The 2,500 pages of the ITU radio regulations, the domestic level FCC filings for radio coordination, the other mission authorization authorities that are at play in the United States. Jessica, what do you think about the application of AI in that example or others that could possibly enhance international cooperation and compliance with space treaties and agreements in any sort of multinational body like that?
Oh, that's where you're going. Okay. I was automatically thinking, can you train them to
Where's the training
to
data,
abide by international law? Because I think that is really a significant challenge when it comes to AI. And that is where a lot of the legal discussion is taking place at the United Nations on the AI regulation side, not the space side. So I was thinking, again, about the need for humans, because international law is not one thing, it's many things, and there's always these judgment calls. And often, if you're in armed conflict, very rapidly changing scenarios where you have to make calls on proportionality and civilian protection and the hierarchy of law. And so I'm not convinced. But one area where I do think we could use AI in the short term, if we're talking about low-hanging fruit, is on that norms discussion that we are having at the United Nations. It's really focused on behaviors and trying to agree to behaviors. And the reason why we're talking about behaviors in space is because oftentimes we can see them and we can monitor them. We can observe. Okay, I can't observe, but some of you can observe what satellites are doing. How are they operating? How are they behaving? And so we can agree to rules that could make space safer, more secure, and more sustainable. We can observe if registration practices are being followed. We can observe if debris mitigation rules are being followed, but that's hard. Being able to do the observing is still the purview of very few states. And so I think there would be opportunity to bring greater transparency to the space environment, greater accessibility to this data, and to understanding what the data might be telling us about how states are behaving in space. So I think that would be feasible. But again, I come back to this culture shift, because I think we're often faced with this security versus security scenario where we have international security objectives, which are what I'm referring to, but those aren't always in harmony with national security objectives, where we want to sometimes exploit lack of transparency, the ability to do things that other states can't do. And so, yeah, I think, again, it's the technology, but it's not the technology alone that will allow us to do these things. It's political will, a willingness to have greater sharing of information, greater accessibility. So again, why I love this panel is bringing these discussions together is really important. But can robots follow international? I don't know. But should I also be driving a robot? I'm not sure.
Well, if it gets easier and easier, maybe you reconsider.
Well, that's what I was thinking with your other question. I was like, so basically you're saying I could be driving the satellite, and I don't know, that doesn't seem like a great idea.
The 4 of us were talking earlier today about some of the scope problems we see with research happening in this space. Or not a problem, but just a function of how university or sponsored research at academic institutions really works. An AI solution set, it might be very small for a very specific problem. So as an example, I worked on a project using reinforcement learning to tell an optical satellite where to point to best update or most efficiently update a space object catalog. But one of my questions when I was working on that project was, where does this list come from of most important objects to observe? There are real political pressures that inform the solution space for AI development. So you're in the room with a bunch of people pursuing degrees in aeronautics and astronautics, and many people watching online who might want to do the same, who are excited about deploying AI technologies. What advice do you have or warnings when entering this space? If they want to have policy impact research, or they want to be able to have a touch point with the communities of research and practice that you three come from.
That's really hard. That's really challenging, because you're talking about, different worlds, right? I mean, there is such amazing good work that is being done on improving the machine learning and the AIs and the tools, and yet there's this whole other world going on of the policymakers and decisions being made that operates under a very different set of rules, and it's almost like, well, go get a second PhD in that world, and then you can maybe marry the two together and find out what to do. But that's really challenging. One thing I would just say is to give some thought to the implementation question, right? It's one thing to solve these problems in a lab or in a constrained setting, but just realize the world's always much more difficult. And by the way, the technology is always the easiest part of the solution. All the other things we've been talking about are much harder to solve because they involve humans, and humans are not rational beings, despite what you've been led to believe in certain cases. And we prefer stories over logic, and we aren't very good at all with statistics and probability. And that's the world you're going to have to deal with, at least for a long while now. So I just keeping that in mind is probably something that's good. And, I don't know if it's heretical to say this or not, but cross-disciplinary work, right? So I've seen projects before where they take, satellite engineers that are building satellites, and then they go get somebody from the school of public policy or from the law school to be like, hey, go figure out the regulatory filings or the licensing process for this satellite, which is a whole other challenge. And those groups working together can be quite interesting.
Yeah, I would be a little more optimistic, but to that last point of interdisciplinary work, I think we're all products of it. Right? The best thing about the space community is that it is incredibly kind and open and curious. I do not have a STEM background at all. I'm an international affairs, policy, national security person, and yet I at least understand the basics of orbital dynamics and of how AI technologies are working so that I can translate that back to policymakers who have even less of a touch point than we do, right? So I think it's important to think about the broader picture of how your technology will be leveraged and used, and make sure that you're communicating in the right way, because often it is like talking in a different language when we come in, we talk to technologists or really deep experts in their space or technology fields. And so if you are really good at bridging that gap and reaching out and being that translator, that's an incredibly valuable tool. And I think we see really incredible cases of this in like national leadership, as well as even on this panel and across the space community. And I think we need more of that, both ways. You need the policymakers to be leaning in, to stay curious and really learn about the technical details and implications of how their policies or their organizations interact with this technology, and then you need the scientists and engineers to lean in the opposite direction and really understand that big picture and be willing to kind of bring in the policy community and merge those two.
Go ahead,
I have a completely sort of different perspective on how you can impact policy, and I think it's through making sure that your own projects, and for those of you with companies in particular, you think about the policies that govern what you do. So what are the values, the ethics, the limits, the guardrails that you are using when developing your technology, when using the technology in the real world, when interacting with others. And I've sort of been thinking about this a lot. I haven't had a chance to write about it, but corporate governance is global governance, especially in domains like space, when the vast majority of objects are commercial, when I think commercial operators really are starting to set a lot of those implicit norms and how we behave, what is acceptable, what is expected in outer space. So I think there really is a real opportunity to show leadership on some of these issues. I think we've seen some of that emerging. You pointed to SpaceX and valuing environmental sustainability perhaps over a little bit of a loss of efficiency. So thinking about how we order our values and how we implement them, I think you can, in a roundabout way, influence policy and influence the governance of outer space that way, just through how you govern yourself and the standards that you set and communicating with that and communicating with your peers. And so, I think there's a more direct way to be engaged.
With just a few minutes left, I want to open it up to questions from the audience. So do start thinking of them if you do have any. And I also asked on Twitter in advance of this panel if folks had any questions for this community we've gathered here. And you can still ask questions on Twitter. I'm at Thomas GZ Roberts. And one of the questions dovetails well with what Jessica was just saying. So it might be challenging to govern the development of AI technologies using multilateral fora. I think we could all agree that might be a little hard. But these AI technologies are developed on shared values, and in some cases, just parameters that help if you speak them. So in the case of collision avoidance, what is the risk of collision that you're willing to tolerate? NASA publishes theirs for the International Space Station. The Space Force does it in a different way by creating collision avoidance messages, which implicitly share their risk tolerances. SpaceX shares their risk tolerances. So suppose these numbers got more and more out there, more and more operators were sharing. Is there an appetite within the multilateral communities, multinational fora, to take on a real international agreement on these sorts of parameters? And where would that be? Would it be the ITU, COPUOS? What can you think of in your experience with these communities of practice?
Yeah, that's a great idea. In fact, there's a huge need for that. Those existing bodies you mentioned, so UN COPUOS is the Committee on the Peaceful Uses of Outer Space. It is the oldest and the oldest body within the UN that deals with space. Is where all the existing treaties came out of. And at the moment, it deals mostly with civil peaceful uses of outer space. There's another body, the Conference on Disarmament, that mostly deals with the weapons, arms control issues. And there's things like the ITU and a couple others that are parts of the UN, but they're specialized bodies. One of the things that I've been thinking about, and people like you are talking about, is, we need some sort of an entity that is doing sort of the technical standardization issue. So if you look at like how the internet is governed, you have something like ICANN, which does the names and address assignments and all the .org and .com and .xyz up here, all that kind of stuff. Then you also have the Internet Engineering Task Force, the IETF, that writes a lot of the standards. So things like HTTP and TLS and a lot of those things. There's nothing like that in the space world that is doing some of these standard level protocols. ISO, the International Organization of Standards, does some work on some things, but not really on like protocol level issues. There's something called the Consultative Committee on Space Data Standards, CCSDS, that does like message formats and stuff. But again, not this level. So that is something that we've been thinking about that may be needed, and is a way that other domains have solved something similar that could be of interest. The other is in the GNSS, the Global Navigation Satellite System world, so GPS, Beta, Galileo. There's something called the International Committee on GNSS, IGC, where the countries that operate those systems get together and share information and talk about interoperability and those things. So that's another construct that is already being used that we're talking about, for example, in terms of space situation awareness data sharing. Because at the moment, you have these various hubs that are emerging around the world. The US military is one, the Department of Commerce has been another, there's the EU SST program, there's several commercial providers. And they all have their own sets of data and their own algorithms and their own products and sets of customers. And so the question is, how do you translate between them, right? And what is the interoperability between that data and exchange of data? And so these things like an IETF setting some interoperability standards, or an ICG-like entity that you can come just say like, hey, we're doing this, hey, we're doing this, maybe we can coordinate. That stuff is currently being discussed as ways to deal with this at the international level.
Are you optimistic?
You know, look, it involves getting governments to agree, many governments. Right now in Copious, there's over 100 countries that participate, and it operates on a consensus basis, which is really challenging. Especially giving any point in time, there's, let's say, some complex geopolitics going on somewhere in the world that involve one or more of those members. But it's not unheard of, right?
But
It happened.
I think what's important to note, though, is a lot of the examples you raised, because I've been thinking about this too. I think standardization is a great way to do governance by stealth. And no one really knows what you're doing, and you can avoid some of the high-level diplomatic challenges. A lot of them are outside of the UN, and so they're global.
Yes.
Global in some cases, not always, but global organizations. But they don't necessarily have to work through the very formal diplomatic processes that can constrain the United Nations, and they can get around some of the geopolitical stuff. And I think truly focus on the technical level, which is hard when you have diplomats at the table. That's not their job, to be fair. I think diplomats are excellent at their job, but it's a very specific role. And so, maybe institutional entrepreneurship is needed here. I agree. I think ISO is a good example of where we see some of it taking place. But maybe this is a problem to be solved where we need an institutional home. And but just so you know what Brian was talking about with the GNSS coordination, that's what allows your phone to hop between different PTNT, I want to say GPS, but that's of course the American lingo, but different GPS service providers. So when you're looking at what capabilities your phone or your watch or other things have, and they'll often list a series. Well, that's because of interoperability and specific efforts to make that feasible. So certainly we've done it before. We could do it again.
Let's jump to a question from the audience. Sir, go ahead. But we might want to run into a...
Just had a small comment. It's interesting that you give ICANN and the internet as a positive example of standardization.
Right.
That was like a miracle that it worked. It was just a private corporation that was started on the fly in Virginia, and I think if people knew what the internet was going to turn into, it probably would not have worked, and now it's got so much inertia.
Yeah, no, that's an excellent point, right? And now trying to replicate that, people might go, whoa, I see what you're doing here, right? And the other beautiful thing about ICANN is it's not controlled solely by governments. It was one of the first examples of multi-stakeholder organizations where the board of ICANN is a mix of governments, corporations, and NGOs that all have a say in the governance. That was really wild and unique.
Recently, ICANN was even private. It actually had government. Okay.
There's also a spectrum within UN organizations in terms of what role civil society organizations can play. You've been there yourself.
Yeah.
And the UN is a state-based organization, and I think multi-stakeholder governance is the future of outer space. So it's interesting because I have colleagues that work on cyber and internet governance, and they look to space like, you guys have treaties, you're so far ahead of us. And then we look at them and we're like, you're so far ahead of us on a lot of these other issues. And so I think we have a lot to learn from one another across domains.
I think we got one more good question in the corner. Go ahead.
Hi, sorry, I'm hiding over here. I'm going to try to make it short. So I face similar challenges. So I work at NASA Goddard. I'm actually remote here in Boston, and I'm an AI, PhD in AI. So I kind of came to Goddard and expected all the different ethical challenges we talked about in my AI program to translate to aerospace, and they don't. So, and I actually also am a mission resilience lead, so I've done a lot with anomalous faults and using AI for that. So it's been an uphill battle, but one thing I offer is considering the human factor, which you guys have discussed. So I don't know if you're familiar with the brown paper on the trolley problem for robotic agents, where we essentially as humans, we prescribe more blame for robots when they don't take action and more blame for humans when they do take action, stuff like that. So I've brought in that to Goddard and it's slowly made headway. So one of the things I was curious is, have you guys done any, this is a tactic I've used, is like highlighting analogous technologies that have had similar issues when first becoming integrated, highlighting things like automated flight and how we somehow don't and granted, I know it's human on the loop, but like this delineation of automation versus autonomy and where the line's drawn, like I just think it's a loaded problem, and the AI literacy at organizations like NASA for sure, sadly, is lacking, the AI literacy. So anything on that, and then I'll stop talking.
I would just say, as you heard us talk a little bit about, I'm a huge believer in looking to other domains, other technologies, learning from that. One of the problems we have in the space world is we tend to think that all of our problems are new and no one's ever grappled them before. It turns out that's totally not the case. So I'm a big believer in doing some of that. And even with the space world, we continuously bump up against the same challenges with the same technology again and again, right? So we are replaying all the challenges and all the policy issues we dealt with in PNT, and then again in remote sensing, now with SSA. Nobody learned, and that's a hugely frustrating thing. So I agree with you, but so I think that would help, especially if you can bring in, look, there's other domains, other technologies, other fields solve this problem. I think that's really important. But at the end of the day, it's still going to be a challenge to get the culture to change and get it through bureaucracy.
Yeah, I think what's really interesting for the Space Force right now is we are fully rethinking what it means to be a Space Force Guardian, whether that is a spacecraft operator, a cyber guardian, intelligence, engineer, and acquisition. So to me, this question really bleeds into a bigger foundational question of what does a modern government organization or military service look like in space. We have inherited a lot of history and a lot of bad culture and good and bad processes. And it's not equivalent across government. The NRO, for example, uses autonomy way more than the Space Force does in places, right? And so we can learn from each other. We can learn from different agencies. But again, I think it's part of the issue is that foundational education and comfort, and part of the issue is actually the integration process and bringing these tools and techniques into in a sustainable way into the organization.
With that, I want to ask you to join me in thanking our panelists.